Hi, Professor. This is Felipe Rosa. We have here Huynh and Sabra, and we're going to present our project for the Smart Home Temperature Monitor System. The system consists of publishers that send temperature data and subscribers that receive and visualize the data, like people in a house that, as a subscribers, wants to know the temperature from different locations, the publishers. Therefore, the system includes a broker, a publisher, and a subscriber. In summary about the process, the publisher sends data to the broker, and the subscriber receives the data from the broker. The subscriber can also visualize the data in a chart. The publisher is a key-based publisher that allows the user to manually generate the data or automatically generate data. The subscriber is a key-based subscriber that allows the user to visualize the data. Now Alice is going to explain about the publisher.
We start with the data generators, which is used to generate the temperature data, and then we have to generate the peak and the valley that we were talking about lab 6. So basically this is lab 6, and then this will return this plot data here. And this function will be called in the publisher GUI. So this publisher GUI, so basically it is a GUI, and then you can see, so right here we have the GUI here that you can basically enter in the temperature and the location, and then you can just add the data points. Let's say you put 25, and the data point will be highlight bold, and then it will say manual, and we'll keep running like that. And then we have multiple publisher, which is managed by a thread pool. So that will be a thread manager here that will create 3 threads and then continuously accept different data and send it to the MQTT communication servers by creating the payload here and then send it. So, and then we also simulate the unreliable of the network by only having like 99% publishing data points. So like probably one data point will be missed. So you can see in the console here. And then this GUI is intended to run automatically upon generated. Yeah, so it's built a canvas here, and then it will just continuously generate. Next, I will let Philippa talk about the subscriber.
Okay, so about the subscriber, we have basically two parts in the code. One is the subscriber g.py, and the other one is multi-subscriber.py. The g-based part it's for data visualization, and the multi-subscriber it manages the running multiple subscriber instance. Also, it has charts that visualize the temperature data and detects missing errors and values. More specifically, on the receiver side, our subscriber modules comes into play. So the simple console subscribing group _4 subscribe.py shows incoming messages, but the true power is on the subscriber g that we are showing right now. In this file, we decode the JSON message, log details, and data counters for total messages and errors, and dynamically refresh a matplotlib lib chart embedded in the Thinker interface. This real-time visualization helps us immediately spot anomalies such as missing transmissions and usually high or low temperatures. Also, it's important to say that we have here to tie all these components together. We implemented a central launcher which is called main-launcher.py. This GUI provides a tabled interface to start and monitor different publishers and subscriber process, allowing us to easily launch and scale our simulation. So our code is modular. The sensor, publisher, and subscriber functionalities are each isolated in their own files. This not only makes the maintenance easy, but also aligns this to the core alignments that we like on this project. This last part I was talking about is the main launcher.py. Now let's switch to the demonstration.
So hello, I will demonstrate the graphical user interface components for our smart home IoT. So our graphical interface not only provides an intuitive control panel, but also offer real-time data visualization and system monitoring. So firstly, I'm launching the main system via the model Group 4 main launcher. You will notice a window with the 2 tables. Here we have publisher and subscriber. So when I launch the publisher, here I can launch our graphical user interface based publisher. In this interface, we can manually enter a temperature, for example, 30, and or leave it the field empty to trigger automatic data generation. The location drop down. So here we can choose either living room, bedroom, bathroom, or kitchen. So if we add data points, we can see here that what we added manually here get in bold. We can also launch multiple publishers. So here we can see we have, for example, the first publication for kitchen, the second one for the living room, the third one for random location, and we can also stop all the publisher. I will launch again the publisher, and let's Philip to discuss the subscriber how it launch.
Okay, so on the subscriber part, we can launch the subscribers there, and when we launch, we can see on the chart in real time all the data that is running from the publisher. If you go to the publisher and we manually introduce a value which is below -30, for instance, and there you go, we have all the dots. The green dot is related to the manual entries that we did, and if you go to the data log, we can see with the different colors. The blue one it's on the range, and the red one is outside of the range, so it's a kind of error. So we also can launch multiple subscribers right there. If we click here, we're gonna have a window. You can just click like 1, 2, 3 times, and we're gonna have now we have 4 different subscribers, and all the windows will pop up like if we are different people from the same house trying to see the data. So in conclusion, our intuitive GUI interface provides both a control and comprehensive feedback. They allow you to interact with the publisher and subscriber, ensuring that data flows correctly and any issues are promptly visible. Thank you for watching this demonstration. I hope this gives a clear understanding of both coding and graphical aspects of our project.